Okay, so this is the video of the piecewise function that we were talking about in class. That would be on the video so that we have one more resource in case you have questions, excuse me. So remember the first thing that we talked about is the domain. Where does this exist? And where does this exist? Okay, so what is the domain of each part? So the first part right here, I have x is less than -1. So -1 is as big as this function will get. So this would be from negative infinity to -1, and then I see an equal sign on there, so I know that it is included. And then I look at the domain of the second piece, and I see, okay, x is bigger than -1, but it's not included. So there's the domain of the second piece. And now I want to find a few points that it's true in the first one and a few points that it's true in the second one. So I'm going to pick values that are between -1 and negative infinity. So here's my x and my y. So I'm going to need some negative values. So maybe like -3, -2, -1. Actually, let me make this green. Oops. Okay. So x and y. Okay. So -1, or not -1, we said -3. So -3, -2, -1, 0, 1, 2, 3. So I've got stuff going on both sides of the domain, from negative infinity to -1, and from -1, and so on. So I see that these values right here are in this part of the domain, the x squared part. And from here down, it's in this other domain, negative x, but there's a hole right at -1. Okay. So I'm going to plug these values in here because that's where the domain is. So I have y equals x squared, and I'm trying out when x is equal to -3. Plug it into my equation, -3 squared, and we get out that y is equal to 9. A negative times a negative is a positive. 3 times 3 is 9. So throw a 9 right there. And then I repeat and do it again. Y equals x squared, and x is equal to -2. So I'm going to plug this into my equation. Y equals -2 quantity squared. If you put this in your calculator, make sure that you're putting in the negative as well as the 2 in parentheses because we want the negative to be squared as well. So we get out 4. And then we have the next one, y equals x squared, and this time we have x equals -1. Y equals -1 squared. Y is equal to 1. So there are my ports for this part of the equation. We'll go ahead and plot them. And notice that there isn't a value in here that I can't plug in for my x's. Same thing here. So my x's go from this range, and there's not a value that I cannot plug in. For example, I don't have the square root of -x where I have to worry about values that I have to put in there. So -3, that would be right here, 9. I think that's about right there. -2, 4. Okay. -1, 1. And the domain was from -1 to infinity. So it's this part of the graph from -1 this way. So my graph kind of goes like that. So this is that first part. There we go. So it looks something like that. And then I've got the other side of the equation. So now I have y equals -x, and I want x to be equal to -1, and then it's plus a very small amount. So small, I'm not even going to tell you how small, it's just such a very, very small amount. Okay, so y is equal to negative, negative, and I'm putting in -1. So y is equal to 1. Okay. So that's where the hole is that 1. Then I repeat, y equals negative x. X is equal to 0. Here's my next point. So y would be equal to negative 0 or just 0. Next one, y equals negative x. X is equal to 1. Y is equal to negative 1. Next one, y is equal to negative x. X is equal to 2. Y is equal to negative 2. Throw that right there. Y is equal to negative x. X is equal to negative 3. I'm sorry, not negative 3, positive 3. So y is equal to negative 3 right there. Okay. So I have got a hole here. But when I have a hole over the same spot, I don't need that. So there, I know it's going to go here. And then the next point is 0, 1, negative 2. And so this line, it looks like we're going like a straight line down. There's no curve to this one. There's a curve to that one for sure. So it went all the way up to here. And it just happened to be the same spot. And then it goes all the way down here. And I put my arrow on it. Okay. And then I need to label this equation. So this one is y equals x squared if x is less than or equal to negative 1. It equals negative x if x is greater than negative 1. Both parts here. Okay, and there's my graph. So I had a hole here, but it happened to be the same spot. If this hole would have been 1 right here, I would have drawn a circle hole there. But we didn't need it because those two spots line up again. Okay, then I have the domain, the range, and interval of increasing or decreasing. Okay, so domain. Well, I don't have any restrictions up here on either one. It goes from negative infinity to infinity. So negative 1, there's a spot, it's going to go all of the x-axis. So if I look at all the x values, it will be there. Oops. Okay, the range, these are all the possible y values. So I'm looking and like, look, it goes up, 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 and it goes to positive infinity, but it also goes down, 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 down to negative infinity. So my range includes all possible y values. So this would be the smallest, which is negative infinity, to as big as it gets positive infinity. So my domain and range is negative infinity to positive infinity. Then I have to talk about increasing, decreasing, and constant. So I have increasing, decreasing, and constant. Okay. So my function, as I go to the right, so I'm always going to the right. So as I'm going to the right, I'm going down, 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 down. So the whole entire function, I am decreasing. I am decreasing the entire time. I'm not increasing. As I go to the right, I don't go up. I'm not going up anywhere as I go to the right. Here, yeah, it looks like it's going up, but if I go in strictly from left to right, it's definitely going down. Oops. So it is not increasing. And although the slope changed and this was rapidly going down and this one's just slightly going down, it's still going down the entire time. So it is not constant at all. Okay. Feel free to watch the video as many times as you want. If you have any questions about this, please let me know. I'm happy to answer questions. Good luck with the homework.